The hidden heroes of the process industry. In the process industry, it is common to initially think of big reactors, columns, and tanks. However, there are equipment that play a much smaller but equally important role in these processes. These are valves, compressors, and pumps. A valve is a piece of equipment that can control, direct, and/or regulate the flow of a fluid by either being open, partially closed, or fully closed in a pipe. A pump is a piece of equipment that moves fluids through mechanical means, while a compressor is a mechanical device that reduces the volume of a gas, thereby increasing its pressure. With up to dozens of pumps and compressors, as well as hundreds of valves on one single refinery, how do engineers design and keep track of all of this equipment? PNIDs, keeping track of equipment. A PNID, or a piping and instrumentation diagram, is an important engineering document in the form of a technical drawing, which consists of symbols and interconnections of equipment. It is a primary schematic drawing that lays out important operational information such as process control installation, piping and instrumentation details, and the safety and regulatory requirements of an entire process. PIDs are vital to process engineers because they help them understand the operation of a plant. They not only show the sequence of equipment during the design process, but helps keep track of individual pieces of equipment by assigning unique codes to each piece and showing how everything is connected. It is therefore very important to keep it up to date for operational and safety purposes. Unlike other diagrams, PNIDs are especially important because they showcase small equipment like our hidden heroes: valves, pumps, and compressors. These are the symbols commonly used to represent these equipment on PNIDs. Use and assembly. This is a ball valve. Like the name suggests, the valve is open when the ball hole is in line with the flow, and is closed when the handle is turned 90 degrees perpendicular to the flow. This is what you need. First, prepare the housing of the valve by attaching the ball seals. Then, slot the spindle screw into the bottom hole of the housing before sliding in the ball itself. Close up the housing like so. Next, insert the O-ring and washers through the screw, followed by both of the stops. Insert the spindle seal after. Lastly, insert one hexagonal nut, followed by the handle, and the remaining hexagonal nut to seal it off. This is a piston compressor. Through mechanical power provided by the wheel mechanism, an internal piston decreases the fixed volume of the device, thereby increasing the pressure of the gas within and thus successfully achieving its duty as a compressor. This is what you need. First, using the hexagonal screws to place them in, affix the side plates onto the main housing unit, ensuring that the internal wheel mechanism is placed inside. Next, place the piston inside the housing from the top and screw in place with an adjoiner on the bottom. Once inside, screw the bottom plates in with Allen screws. Once the plates are inside, affix the top plating section of the compressor with extra long screws using the plate guards. Then, attach the wheel guard to the appropriate side. Affix the filter and nozzle to the top section of the compressor before finally attaching and screwing the wheel mechanism itself to the correct side.